So this is a kind of another look at the Selwyn Basin. But this, while I'm not the geologist that wrote this, these comments and observations came from Rob Cairn, who was then president of ATAC. And we asked what happened with this. Was a you can see the outline of the survey with this one here. It's a pretty big chunk of ground. In fact, it was the largest airborne survey of its kind ever done. And it was done by a private company who had some exclusivity to the ZTEM system through funding some of the latter stages of development in 2006, 2007. So this group went out and, because one of the principals of this group had worked in Hudson's Bay, Hud Bay had actually worked in this area being a zinc company. Back in the 50s, as far back as the 50s, they were actually doing mining in parts of the Yukon at that time. So this guy came out and he says, hey, this is a great place to look for zinc. Let's use our new whiz-bang ZTEM system. They flew 25,000 kilometers, and then they left. They literally left the province. That data set sat there for, I think it was 6 years. And finally, of course, that junior spent all their money. I won't say they went bankrupt. They no longer had funds. And they leased the data to Tech for a couple of years. But it was floating around, and the suggestion was made to Mo Colprin's boss, Carolyn Reif, that the Yukon Survey should buy this data set and add it to their inventory. It wasn't what they normally did, but they got it for pennies on the dollar. And then in 2013, we worked the data up. It had been processed by Geotech at the time in 2008, but we did some further work and made some map products, and then we had a workshop. And in that workshop, Rob Cairn put together observations from a person who had worked in the Yukon for 30 years as to what had he, if he was an explorer looking for zinc in the Yukon, which he said would have been great 10 years ago, but in 2013 nobody cared. But anyways, that was the observations are still valid. So I kind of just high-graded his comments and said, okay, if you have a big regional data set, what are some of the things you can do to look at it and try to gauge whether it can help guide you to do further work. Lines here, as I mentioned earlier, are kilometer spaced, but they went to half kilometer over a number of mineral deposits and areas of interest, and so that's what the purple bits are. System, you've seen that. This is the sort of product that we made for the Yukon survey. So we have these panels across the top that show the topography and various parts of the EM data. We show that always we think it's important to have the primary data profiles. The other guys have been showing that as well. Magnetics data, a layered earth inversion of the EM. It's actually a 2D in this case, but anyways. Then you've got derivative products of the mag, a 3D solution of the mag here, and then the best geology that they had available stuck at the bottom as a plan map. So for every line, that sort of product is made as a high-res PDF. There's the geology. Sorry.
For reference, did the survey go forward to the slide that showed the complete area there? Is Faro on that for reference?
No, Faro's down. Jason and Tom up in here, Howard's Pass, Faro, and Kutzakaya down in here.
Okay, thank you.
Yep. I think those ones are more of a massive sulfide affinity, and they fly like a time domain EM, whereas these are more, they thought, structurally related, more Sedex stuff. Yep. So that's the geology that was known at the time. To my knowledge, they haven't actually gone back and tried to do a Mo-Colprin reconciliation. They could at some point, but this was, and there's this road goes down to Ross River. I forget what the Canal Road or whatever. It goes up to the stops at the Northwest Territories boundary there. So a little piece of this is actually in the NWT, and then because it's geologically covering the Selwyn Basin, which didn't know about the provincial territories boundaries when it was formed, but the bulk of it's sitting inside the Yukon. And these all are intrusive bodies that will be quite obvious here in a second. So there's the magnetics data for the image, and you can see the boreals around a number of these intrusions. Definitely skarnification developed all over the place, even where there's not mapped intrusives. You can see the low associated with the intrusion, and then the edge, boreal edges around it. So it just a very, very consistent pattern. Go back to the geology. So you can just sort of, you could spend a lot of time toggling back and forth, but it's these things here. Some of the smaller ones they catch, depends, but there's a number of covered ones too that we know hadn't been recognized before. There's mapped Cretaceous granitic intrusions, and they're overlaying. So a very high set of coincidence, but also some newer, smaller features. Interesting potential here for gold, intrusive related gold. And it was, Sean Ryan actually went in and staked a lot of what he thought was prospective for the intrusive related targets in 2013. The guy that found, was it white gold, I think. So he's got some money to spend on that, so pretty good correlation there. Conductivity, clearly mapping morphologies and as well quote-unquote structures. And these intrusive bodies just stand out so clearly in these images. It's quite obvious where these things are sitting. So sort of a geology map done in 2 months that would have taken 10 or 15 years probably of conventional mapping. I mean, it's not telling you what it is geologically, but gives you potentially a focus that you could use to get in and understand the geology much faster than just looking at some older photos and trying to start doing it the conventional way. Here we have intrusions and conductivity bodies. So strong correlation with these around them. The intrusions themselves are resistive. That's pretty characteristic, but there's certainly, you can see how the sediments bend around them, picked up with the Z10 quite effectively. Here we have it's kind of, Rob is doing an overlay of the conductivity and the geology. Faults. This is an interesting one because you say, well, why would it not be a perfect match? But down in here, see that edge there, almost a right angle in the EM? There's a piece of, excuse me, a fault map there. What's wrong with this whole thing here? That linear, almost straight edge ruler linear has not been recognized as a fault, but there probably is a bounding fault beside that, just as there is over here. You can see a little bit of a reflection of maybe that fold structure there. There's that angular one here, but then there's a piece of conductor going off. You can pick your favorite one. Why does it get that edge there? It seems to catch an edge here, but then it goes right through the heart of a conductive body. So you could do a lot of wiggling and reconnecting some of these things and adding definitely some more, once you buy into the concept of that line running down that structure, that feature is a structure, the whole thing becomes a structure. It doesn't stop. I mean, the EM feature isn't, it continues, so it has to have some reality of its own. So you put a box around the major EM features, and his attitude was, other than maybe chasing some of these intrusions out in the blue area, the main action from a minerals perspective are these 3 big, not quite including this, but these 3 big bands through here that pretty much most of the rest of the geology would probably be second order. He was intrigued with, he called them recessive linears. And just look through I don't know the topography there. But then you go to the Z10, and you can see these corridors. And I don't know if those are like Mo's phantom structures on his project, but something that correlates a bit with topography, but from Rob's point of view had very interesting implications as far as structures that weren't really mapped through other means or showing up with that EM data. And pointing up towards his RACO project, which was, I think, mainly on mineral occurrences. This is where it starts to get exciting. Why are they all in those conductive zones, more or less? There's a few scattered down in here, but here, the majority, here, the majority, they're all in those corridors. Drill prospects, significant showings. Just toggle through them. They all, it's like he had the lines there to start, and then he had to put all the important stuff inside them. But he just said, I wouldn't have believed that a geophysical map would provide that much sort of showing these highways of where all this mineralization is occurring. And it's not that, you know, there's definitely, well, that's interesting, that sits right on that structure, as does that one. That's just off a little bit. There's a few rogue ones, but there's no coherency to them. The ones that all stick together, it's saying there's something going on in those highways that associated with mineralization. These are all in your notes. I thought it was just interesting to see he really got stuck into this. Hopefully he was at a large bottle of scotch and something else to go with it. But everybody was pretty impressed, and he says, "Oh man, this is great." So SKARNs, pretty well everything under the sun: the Sedex, the barite, nickel, molybdenum, garlantite. Well, this was his fave, right, because of the work on RACO. He thought there might be some of these little TP guys. Where's their stuff? Oh, here we go. He's got one up in there. So at least he got one site where he thought there was some affinity with new deposit style in the Yukon, anyways. Claims, and this was all that was all Sean Ryan's staking. So, point being, he believed the corridor, but he believed it hadn't been sampled properly. So go to the place where nobody found stuff before that's inside the prospective highway. That was his logic. Hey, guy's got money. But he did cover, I think some of this, I think these are held by others because these are where some of the, like the Howard's Pass stuff sits in here. So that sits in that big corridor. Extends out into that. I've seen that before.
Are the areas outside those corridors sampled significantly enough to confirm that, yeah, they're actually not mineral bearing and it's just limited to the corridor? Or is it coincidence that they went and sampled those areas for other reasons, you know, because they suspected something?
Yeah, well, I mean, this would be multi-pass stuff, right? Governments would be systematic and take their time, but they would probably cover all areas without bias, you know, that they could get to. And also, one of the advantages through here is this road. So your logistics, you know, for either traversing, there wouldn't be any logging up in here, but, you know, it would mean your helicopter flights or float plane, if there were lakes, would be, you know, it's a pretty good logistics corridor. So, and then the prospectors, of course, they would go, you can see there's claims all over the place. So there's people who've gotten round and about, as they say, and I think investigated it for whatever they thought, you know, would be, just like up in here. Some big packages. There are some deposits up in there that they're conductive, but he hasn't made a big corridor around them. Maybe he doesn't feel there was enough data, or that they were being biased by the intrusions. So.
You mentioned Howard's Pass zinc, is that on there?
Yeah, that's in here.
That's down there.
And then the McMillan Pass stuff is up in here. The Tom and the Jason I showed before. So it's kind of like a branch of that. Now, one of the go crust. Why does it stop? Why does that one stop and that keeps going? But definitely, it stops. There's something. And this is an area that the GSC had never bothered to put any real good regional data in. This is really, really old, like 1960s half-mile spacing stuff. So this definitely lifted the game from an understanding perspective. So gets into a bit on the environment in terms of the settings for Howard's Pass. We'll look at that in just a sec. This is a zoom in here. So that's the block series of zones within that package. The purple is their claim outline, and the black lines are the Z10 lines across here. So that's basically the ore horizon with localization along it. Let me see if I can. There we go. Drilling is always a pretty good metric for package there, here, 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 up here, and up there. So kind of a semi-periodic dusting of dusting. It's quite a significant resource. So that's the low-frequency Z10 data. And we can see here the package that's linking it up. Nothing too much to the north that we see, but certainly most of the major zones of mineralization fall within that structural feature, or lithology / structural feature. Here's a higher frequency version of that, with some interpretation being provided. Well, actually not. Yeah. I think we did a small amount of work for the owners of this, but it was a very, very cursory exercise. But certainly the zones show up in this kind of crappy yellow colors. Yeah, I'm not sure what some of them are sort of a dirty brown. So another EM product showing structures, folds. Oh, here we go. Here's the mag, the tilt, which is effectively our high frequency product. And what's interesting to me here is you also see a direct correlation with magnetic anomalies in an environment that historically people had said there's no magnetic response associated with these deposits. And it's there, even with this very wide space survey. So my recommendation to the folks here was go get yourself a 50-meter spaced Stinger mag survey, and you would see a lot more. You'd have a 20 times better spatial resolution. It'd be stunning, but no, I don't think they've done that. So that was Pebble, and that was the Selwyn. So who's next?
That's it, really.
Oh, that's it.
Yeah. Questions? I got a couple written in. There's one. He's got a question for you right there.
Question, how does ZTEM compare with MT data?
MT is the big brother, because with MT you record the same EM data, but you also get an electric field measurement. Because you've got electrodes on the surface, the ZTEM's up in the air, so it can only measure the magnetic component. We call it the tipper. So the MT allows you to calculate an absolute resistivity, whereas with the ZTEM it's a relative. We do come up with numbers that look like resistivity or conductivity, but they don't have the same rigor that an MT survey does. MT as well, because it's a stationary ground-based technique, can go to frequencies that the ZTEM can't because it's moving. Okay? So MT surveys often record well below 1 second, whereas the ZTEM, it's 10 times higher than that. And then at the high end, MT surveys can go to like 10 kilohertz, but there's not enough signal for the Z-TEM because the system's moving. The signal is there, but since the aircraft is moving at about 100 knots over the ground surface, there's not enough data recorded to allow you to process it. So we're limited to that band of about 30 hertz to 700 hertz.
How about depth of looking at it?
Well, the lower the frequency, an MT has that, the lower the frequency, the deeper you can go. So, I mean, you get into crustal studies and people sit there for a couple of hours to record a single frequency, or days, and they can see down 20, 30 kilometers. The Z-TEM would tops out. I mean, we've seen data, we've seen modeling with drill control and MT control down to 2 kilometers. That's our group's record. And we haven't seen too many cases where anybody's had anything deeper that we believe.
Someone wrote me a couple of questions.
Sure, yeah. Yeah. Oh, well, Abraham's getting
Yeah,
that
we can
together.
do that.
I wrote, this is sort of the basic list which you should get out of one of those DIGIM surveys. I'm not sure if you folks have been exposed to that. I mean, how many people in the room know what a GDB is? Okay, Geosoft database. That is an industry standard in the geophysics world and in parts of the geological world that the contractors will provide the data in. There was a question earlier this morning, and we call it, say, an Excel or a flat file. That's another way of presenting it. But the GDB is a more efficient way. There is a free viewer that Geosoft provides that allows you to read these databases and do a certain amount of work with them. And that's in a way the reason why that's provided. I think you often have those floating around your system, GDBs. Or is it more?
We publish them pretty much. Yeah, all the newer ones.
But Excel should be included as well. And then in terms of map products, you'll see a bunch of PDFs of maps, but there'll often as well be a series of Geosoft maps being provided, but I haven't seen too many that have come through the DGGS system. And the advantage of those maps is that you can rescale them, you can turn things off and on, whereas the PDF is locked. Once it's made, it's fixed. And again, there's a free viewer to allow you to work with Geosoft maps. Grids, again, you're going to say, what are these Geosoft people around the world? They provide a grid format that's pretty commonly used. There's a few other standards.
You can actually get an extension of ARC.
There you go.
To look at the Geosoft.
So one of the ways we find with a lot of our clients who aren't really GIS, into GIS, is they'll use GeoTIFFs. And GeoTIFFs are a way of getting registered images into the computer. There's a number of applications that you can do. One of the things that was touched on that we like are anomaly databases. And Adam actually mentioned this, but what was developed years ago, because the DIGIM system, the name stands for Digital EM, and they were the first group to write a computer program that actually auto-interpret the profiles to generate anomalies from that. And with that, they can tell you something about whether they're culture, or they're flatline, if they're vertical, or they're dipping. That is a standard product that Geoterix, Fugro, CGG have provided for ages. However, with the DGGS databases, this was not always consistently provided. And I've talked to Abraham about this, and at some point, not tomorrow, not next week, and maybe not even next year, but all of the products that are normally generated with these surveys will be available on the online platform that they've worked out, which is a great thing. The other thing that we always like to see is the contractor's field logistics report, and that's also hit and miss. But that's one of the places where things like projection get talked about. Because a lot of these maps, when you look at them, particularly the older ones, there's no projection information. It's mystery meat. Yes?
When you took a high resolution imagery of the fluid lines, is that available?
The videos.
Yeah.
The newer surveys, yes. Not online. The older surveys, we actually have a project right now to digitize all of VHS before we lose them, and those will go out as we sort of put survey online. We'll put those videos online. The newer ones that we have, so the newer ones we just have MP4s or whatever API files. We've just published those, so those are all available. It's easy. The VHS ones we're not really in a position to distribute those right now, but any day now those are going out for digitization. So at that point, we'll be able to distribute those files.
We need to talk to you about
Yeah, if you want it, talk to me. And if it's one of the digital ones I give it to you right now, if not, we have to wait. There's about 10% of our surveys have sort of everything at your fingertips, then 30% have sort of the core data, like it's beginning online, and then the rest of it, CDDs, DVDs, or or stuff when we get a request, like, can I have every bit of data? And I can't wait until I have all the digital files sort of organized, so it just takes me 5 seconds.
Requested,
So
you don't listen to me. Come on.
I think you're one of them. Okay, so I only got written in 2 questions. It was good we asked them so late, but we actually touched on the first one a little. How can we look for placer deposits with geophysics in general? And my answer is that's relatively tough, but you'll never, if you want to detect the placer gold, sometimes you're lucky enough to have magnetite with it. And in that case, maybe you'll search the magnetic anomaly for that. And someone's going to correct me on this if I don't like my answer. You can potentially map at least the limit of your fill in the valley. And the other example so in that case, you can map that with possibly the Airborne Geophysics, or you might have to get into a seismic method, which is kind of expensive. Refraction seismic would be the cheapest in that case. So that's a quick, 2-second answer. Ken, Adam, you have any other?
What did Mo show us that we was mapping that channel that was displaced? Was that EM or MAG? I can't remember.
I think it was certainly MAG, because he said that they were lucky. They had a lot of magnetite associated with their placer.
Right.
And I actually had a placer miner come in and ask me about this, because they had essentially just a valley and 2 different types of fill, and one of the newer fills was somewhere within the valley of the stream and kind of migrated across it, and they said they had magnetite with it. I told them the cheapest geophysics you could do would just, and see if it works, would be just walk a little ground mag survey and save yourself drilling, or save themselves scooping with a bucket randomly across their valley. And then second question was about coal deposits. That's we talk all day on that, but that's typically a seismic method is fairly common for delineating coal lenses, because it might have a velocity contrast. So you'd be going into reflection seismic survey, which is like what the oil industry uses to look for oil and gas.
There is where crops, it often gets hit and burns, hit by lightning and burns, and it gets a remnant effect, so you can see a crop line of coal sticking out in the magnetic survey, because it's this highly disturbed line, and it's just because the clinker, and sometimes it's still burning, right? I mean, these things can go on for a long time. But that geophysically is, if you've got magnetic data, you can sometimes see at least the top of the coal seam because of that effect.
So does anyone else have any other questions? You have 5 minutes, or you can hunt us down throughout the conference. I'll be sitting in front of the DGS booth here and there, so you can hunt me down anyway. So, with that, I'll leave it to our...
Let's keep these guys thinking.